All right, so in today's lesson, we're going to be learning about special right triangles, and one of those triangles is called a 45, 45, 90 triangle. Now, this triangle is created by bisecting a square of 1 square units. So you should notice that on the handout, I have a square drawn, and the horizontal length measures 1 unit, and the vertical length also measures 1 unit. And we are asked to find the length of the hypotenuse. So I'm going to go ahead and outline that, because whenever I bisect the triangle, it creates a right triangle. Notice I cut the square in half and it creates 2 right triangles. And on Wednesday and Friday last week, we learned that we can find the missing length in a right triangle by using the Pythagorean theorem. So A and B represent the legs of your right triangle, which in this case both measure 1. And C would be considered the hypotenuse. So if I ask you guys to simplify this to find the length of C and simplify the radical, what would the length of the hypotenuse equal to? So simplify and solve that equation to find C for me, please. 1 squared is 1, and 1 plus 1 is equal to 2. Now remember that the last step in Pythagorean will be to take the square root of both sides. Are there any perfect squares that divide into 2? Remember, the perfect squares are 4, 9, 16, 25, or even if we were to do our factor tree. The factors of 2 are 1 and 2. Are there any pairs? No. So when we have no pairs, then that means that we have to multiply those values back, and they both go back into the radical. So the square root of 2 will stay the square root of 2. It cannot be simplified any further because the square root of 2 doesn't have any pairs. So what we have done is we've used the Pythagorean theorem to help us identify the missing length of our right triangle. Now, we did this because a 45, 45, 90 is a special right triangle. It's called an isosceles right triangle. Which means that it has 2 congruent sides and angles. So isosceles triangles was one of the triangles that we learned about earlier last semester. Okay. Notice that we have a square, and we all know that squares have 90-degree angles. But if I bisect, and bisect means to cut in half or to divide in 2, and I have a 90-degree angle that I'm cutting in half, what would the measurement of each angle be equal to? Again, think about this angle in the corner, we know is 90 degrees because it's a square. If I divide it in half, what's half of 90? John P. says 45. So again, this also goes to prove why this is isosceles. Isosceles means that 2 angles are the same and 2 sides are the same. Now the sides in a 45, 45, 90 triangle have a special name. They are called the legs of your triangle. And these legs are always equal. Again, they're equal because this triangle is isosceles. And the hypotenuse is going to be equal to the length of the leg times the square root of 2. What makes this triangle special is that the ratio of the sides is 1 to 1 to the square root of 2. So we can use these proportions to help us find the sides in any 45, 45, 90 triangle. So what is important is that on the side, you guys want to go ahead and draw this triangle. Notice again, this triangle has two angles of 45 degrees and one angle of 90 degrees. And the legs are always going to be the same length. So I mentioned last week that the way I like to identify the legs in my right triangle is to highlight them or outline them because they always form an L shape. So if you can hold up your thumb and your pointer finger and they form an L shape, it's one way that you can identify the legs. And the legs will always be the same. In other words, they are equal. And your hypotenuse, which is always across from 90, can be found by taking the measurement of the leg times the square root of 2. Now, this concept seems a lot more complicated than it actually is. Okay, notice I have my right triangle in example 1. The first thing I like to do is outline the sides, the legs. Now your legs can be backwards, they can be upside down, but remember they have to form an L shape. And because I'm a visual learner, I like to draw arrows going from one leg to the other because this reminds me that they're equal. So if one leg is 9, then the other leg is also 9. As far as the hypotenuse will always be across from 90, we know that. And it is equal to the leg times the square root of 2. Now, we don't actually like decimal values. We want an exact answer. So to find the measurement of the hypotenuse, x, all you have to do is replace the leg, which is 9, into that format and write it as 9 square root of 2. So you're going to plug in the measurement of the leg in for that length. So now I want you guys to see, can you guys help me identify the measurements of M and N in example 2? Identify your legs, find the hypotenuse, and drop it in the chat so I can confirm that you guys are correct. All right, so again, guys, the key for the 45, 45, 90 triangles will be to identify the legs. The legs, the analogy I'm giving students in person, we both have 2 legs, right? We have a left leg and we have a right leg. And our legs are the same. So if one of our legs is 8, then the other leg should also be 8. And the hypotenuse will always be the measurement of the leg times the square root of 2. Now, working backwards a little bit, what if I give you the hypotenuse and I ask you for the legs? You can do this by dividing by the square root of 2. So notice here, my diagonal or hypotenuse is 9 square root of 2. I divided by the square root of 2, and we know that when we divide a number by itself, that number cancels. So the square root of 2 on the top will cancel with the square root of 2 on the bottom, leaving us with L. On the right, 9 square root of 2 divided by the square root of 2. Again, the square root of 2's cancel, leaving us with 9. So the legs in each triangle measure 9. And again, same concept. The legs are the same. So if one leg is 9, then the other leg should also be 9. Okay, so similar example. What if I give you the hypotenuse as 11 square root of 2? And I want you to find the legs. So you're going to divide 11 square root of 2 by the square root of 2. And any number divided by itself cancels. So the square root of 2 cancels, leaving us with 11. So this means that our legs measure 11. And again, for our visual students, you can outline those legs, and if one leg is 11, then the other leg is also 11. They must be congruent because these triangles are isosceles. All right, so as I mentioned, guys, these next two examples, they don't necessarily follow the pattern correctly because we're told that if you have the hypotenuse, you're going to divide the hypotenuse by the square root of 2. So my hypotenuse is 20, right? It's the measurement across from the 90 degrees. If I divide 20 by the square root of 2, nothing cancels. So this is why we were told or shown how to simplify division of radicals. We're not allowed to have a radical in the denominator. So to cancel the radical in the denominator, we multiply by the radical on the bottom. Notice it's all coming together now. Everything that we've been learning from about 2 weeks now, it's all piecing together. Radicals, Pythagorean, square roots, it's all coming together now. Since 20 is a whole number and 2 is inside of the radical, I can't combine them. So I simply write these values side by side, making it 20 square root of 2. In the denominator, the square root of 2 times the square root of 2, notice both of these numbers are inside of the radical. So 2 times 2 gives me the square root of 4. But 4 is a perfect square. And hopefully we know what the square root of 4 is equal to. What number times itself is equal to 4? Anaya holds up 2. I agree. Now, what we need to do is simplify our fraction. 20 divided by 2 is equal to 10. And again, since we couldn't simplify the square root of 2, that stays the same. So the legs in this triangle measure 10 with the square root of 2. But there's a shortcut that I want to show you guys. And the shortcut is when the hypotenuse is a whole number, and the key word here is whole number, you will divide it by 2, and multiply by the square root of 2. So without having to do the process of dividing by a radical, if I just take 20, which is my hypotenuse, and I were to divide 20 by 2, that gives me 10. And then I just attach or multiply by the square root of 2 at the end. And a pattern that you guys can hopefully recognize is that the number on the outside times 2 is equal to the hypotenuse. 10 times 2 is 20. So that's like a shortcut rather than having to do all of that division and simplifying. So if we were to do the shortcut with the example to the right, and I have my diagonal of 6, and I divide it by 2, that gives me a measurement of 3. So the legs would equal to 3 with the square root of 2. Again, just double checking, make sure that the number on the outside times 2 is equal to the hypotenuse. Now, we're actually going to go ahead and cut the lesson in half today. So what I want you guys to do is go to Google Classroom and go to the Desmos activity that is posted called Special Right Triangles. And we're going to go ahead and complete slides 1 through 3 today, or at the moment, where you're asked to identify the missing sides of the triangle using 45, 45, 90 triangle properties. So I'm currently sharing the screen of what the activity should look like. Notice the first question or the first slide says, if a triangle has side lengths of 1 unit, how do we find the diagonal length? We discussed that at the beginning. Dividing the triangle down the middle diagonally creates a right triangle. The property that can be used to find the length of the diagonal is Pythagorean theorem. And we actually already did that on the lesson. So if you wrote it down, what would x equal to? Notice that Desmos has a calculator button at the bottom so that you can type in your mathematical answer using symbols. Then slide 2 has you guys determine if the square is cut in half diagonally, what would the measurement of each angle equal to? Again, that was discussed at the beginning of class, the beginning of the lesson. After you answer questions 1 and 2, you want to go on to slide 3. Slide 3 is where I really want you guys to apply these properties to make sure that you understand how to find the missing side length given one of the measurements in your right triangle. Remember that it follows a pattern. The legs are always going to be the same. And the hypotenuse is always equal to that measurement times the square root of 2. So I'm going to give you guys about 10 minutes to work on slides 1 through 3, where you guys are asked to identify the missing measurements in the table. Let me know if you guys have questions as I walk around the room. All right, guys, so I know that there's confusion on slide 3. What I'm asking you guys to do is to fill in the table based on the measurements that are provided. Now, we discussed that the legs in your isosceles triangle are always going to be the same. So in the table, they give us the first leg measurement as 1. If one leg is 1, then the other leg is going to be the same. So if x is equal to 1, then the other x is also equal to 1, and the hypotenuse would be 1 square root of 2. You are replacing the x with the measurement of the leg. So then in the second example, they say, okay, well this time the leg is equal to 2. So they're changing the value from 1 to 2. If one of the legs is 2, what should the other leg be equal to? 2. Remember, your legs are congruent. They're the same. And the hypotenuse, if I replace the x with 2, this would give me 2 square root of 2. So in your table, you are typing in these values, 2 and 2 square root of 2. Now, the third measurement that they provide is 4. So they're saying, okay, well, let's start over. What if I have a triangle now where one leg is equal to 4? What should the other leg be equal to? 4 And the hypotenuse would be 4 square root of 2. Again, all we did was replace the x with the measurement of the leg. So I want you guys to finish the table based on the measurements provided. Okay, remember that the legs are always going to be the same. So we are asked about the second to last one, where one of the legs is equal to the square root of 3. Remember, your legs are equal. So if one leg is the square root of 3, then the other leg is the same. So in your paper or wherever you guys are writing this down, just remember that the legs are x and the hypotenuse is x square root of 2. So in the third column, we know that x is equal to the square root of 3. And we multiply times the square root of 2 to find the hypotenuse. Since both numbers are inside of the radical, the square root of 3 times the square root of 2 can be simplified. You can multiply the two numbers, giving you the square root of 6. Now we are also asked about the very last row where we had that fraction, and a lot of you are intimidated by fractions. The square root of 2 divided by the square root of 5 can be rewritten as 1/5 times the square root of 2. And the reason why I'm choosing to rewrite it in this format is because x is the number in front of the square root of 2. So what's the number in front of the square root of 2 in this case? 1/5. So this means that each leg is 1/5. Going back to the third row, if one leg is a half, then the other leg is also a half. Use your slash. Therefore, the hypotenuse can be written as a half times the square root of 2. X is important. X represents the length of the leg in these triangles.